Thank you. I would like to welcome everyone to our TIES webinar on data science for environmental applications. And I'm delighted to introduce today Natasha Stavros from University of Colorado Boulder, who will talk on wildfire problems, which is one of the most important problems right now at the interface of climate resilience and sustainability. And Ignacio, so take it from there.
Yeah, thank you, Julia. Thank you so much. Well, as Julia mentioned, welcome to our today's webinar session, everyone. This session consists of 40 to 45 minutes presentation and 10 to 15 minutes for questions and answers. We suggest attendees to ask questions at the end of the presentation. We are so glad to present our today's speaker, this TIES webinar, Dr. Natasha Stavros is Director of Earth Lab Analytics Hub. She specializes in complex system science, data science, image processing, and information technologies. She developed these skills as a fire ecologist, but has applied them in other complex systems, including NASA flight projects, biodiversity science, and urban ecology. She's an engaging public speaker and has participated in TEDx, given a talk about uncertainty under decision making and the role that's playing in our response to climate change and natural disasters. Dear Natasha, thank you so much for accepting our invitation and making time out of your really busy schedule. Welcome.
Thank you so much for having me. I'm really honored to be here, and I'm really excited about this topic. So thank you for giving me an opportunity to talk about a little bit about what I've been working on and kind of working with a big team of people to develop out through time. So as my talk title indicates, I'll be talking about resilience technology, value-added analytics for the wicked wildfire problem. Oops, there we go. So first I'll start with an introduction to what sort of why we need resilience technology and what it is. And then I'm going to walk through a case study around wicked wildfire and the wicked problem, as well as a model for research commercialization and a wicked analysis. There's a play on words there, which hopefully you can appreciate by the end of the talk, but a wicked analysis for information product definition and how we can hopefully find climate solutions around the wicked wildfire problem. So as we know, there's a lot of drivers for global change, from population growth to global warming. And this is leading to changes such as urbanization, desertification, biodiversity loss, of which we are in the 6th mass extinction of the Earth since its creation, as well as climate change, which leads to changes in extreme events such as wildfire. With these changes, we are looking for mitigation strategies, and this is where the idea and concept of resilience comes into play. And the idea is to prevent, not to prevent the disturbance, but to prevent the impact of the disturbance, to withstand and respond and recover to those disturbance events. So when we think about it, leading questions in disturbance and resilience ecology can generally be binned into 3 major questions. The first is, how and why does life organize across scales? This touches upon topics such as disease and infestation, evolution, food security, type conversions, migrations, extinctions, etc. The second question is, what are the expected impacts of disturbance on how life organizes across scales? And this is kind of related to habitat fragmentation, settlements, land cover and land use change, etc. And then finally, how do we mitigate our climate risk to ecosystems and communities as a function of vulnerability, exposure, and hazard? So recognizing that those disturbances are affecting us, how do we mitigate that? And that's really where we think about storms, fire, water commodities, food security, sea level rise, etc. And so we are better positioned now than ever before to answer these questions, to inform a more resilient future. because we're in the information age with big data and cutting edge analytics, as well as cyber infrastructure and compute resources to be able to harness all of that. We have observations we need, spanning public and private records, remote sensing, genetics, census data, Internet of Things, climate and weather models, facility reporting, stream gauges, and weather stations. So you can just see here that this is really the data we need that's at the intersection of all three of these questions. And so we're really well positioned. But what's needed to actually take advantage of all these advancements for sustainable solutions is resilience technology. And so what is it? What is resilience technology? Well, I define it as synthesis and interpretation of diverse big data using artificial intelligence and data fusion across scales for solutions-oriented science to create value-added analytics that address questions in disturbance and resilience. Whew, that is a lot, right? There's a lot of jargon-specific terms in there. So I'm going to take a minute to define each of these terms: artificial intelligence, solutions-oriented science, and value-added analytics. I'll start with artificial intelligence. It is the theory and development of computer systems to enable and perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. And specifically, if we focus on decision-making, we can see that AI can make decisions, but it doesn't have to. AI can also enable human decision-making with intel generated via computer systems. So it's not to say that we're trying to remove humans from the loop, but we can use AI to give the appropriate intel for humans who are still in the loop. Sorry, this is not working. Okay, so what is intel? And if you sort of break it down, it's intelligence, and it's the ability to acquire and apply knowledge and skills. And so using the knowledge hierarchy, which was developed in the 1970s, some have defined wisdom as accumulated knowledge that enables application of concepts from one domain to new situations or problems. And so really often when you hear people talk about the knowledge hierarchy, they really overemphasize data to information to knowledge, and almost never do you hear about wisdom. In fact, in a huge literature review of the knowledge hierarchy, only 3 references mentioned wisdom, and of which I've now got a 4th reference to it in the literature. So it's very rarely talked about, but it is really crucial because wisdom is the action informed by our values and the patterns of what we know to be true within a given context, based on patterns of information collected from the evidence or data that we have available to us. And so you'll notice in there the word values, and that word values is going to come up a lot in my presentation, because that's really at the heart of solutions science. So what is solutions-oriented science? It's scientific discovery that can inform how we act. And how we act is really determined by the policies or the rules that govern us, the economics or the markets for exchange that we use, sociocultural factors or the social constructs that we abide. So social constructs are things like race, gender norms, cultural values are all social constructs. And technology, which are the tools that we use to navigate within that space. And you can see here that this spells PEST, and PEST was developed in the 60s by a business professor who stated that if you want to change the current business environment, you need to understand the changes that need to happen in policy, economic, sociocultural factors, and technology, not simply just technology. I don't know, my animations are like really slow here, I apologize. So if we think about PEST, identifying the information product for changing the current state, requires understanding the informed actions by people and the processes that govern them. And so this is really where WKID Innovation comes in. It uses NASA system engineering and the knowledge hierarchy and PEST to identify and define intel from data. So this, what you see here, is called the V model, which is used in system engineering for product development. And I've mapped in the knowledge hierarchy with WKID there for you to be able to see it. And PEST is right up there in the very top with wisdom. So why is it so important to use this sort of systematic approach? And it's because systems are defined by the processes for interactions between people, hardware, or broadly the infrastructure supporting the system, software, which is the means of communicating. And so in the 21st century, we think of hardware and software as solely related to computers, but that has not always been the case. And you can think broadly of hardware as infrastructure and software as communication. And so all of how we interact, these processes, are informed by PEST, or policy, economics, sociocultural factors, and technology. And so you're going to see me come back to that frequently, because that's really the basis of where we can start to define artificial intelligence, or define parameters for designing artificial intelligence that is of value. And so this kind of goes into the question of what is value. And if we want artificial intelligence to truly be a solution, it needs to be sustainable. And that means it has to have value. Well, value inherently has cost. That means that the values of a group of people are worth something. To hold those values, people are willing to pay for them in time, energy, and money, or some other means. Morals, maybe. So value-added analytics is then analytics that people are willing to pay for, whether that's monetary or otherwise. And so really what we taught when we think about resilience technology and sustainable solutions, we need to think about the ability to go from research to commercialization. Oops. And so that is really the basis of my talk today. I'm going to provide a case study for developing a model for research to commercialization of value-added analytics for the WKID wildfire problem. I'm going to first take a step back before we dive into what that model is, to just get us all on the same page about what is a WKID problem. It sounds like I'm just, using a word that sort of rhymes with and is sort of punny with the framework that I've created. But in fact, in complex systems science, WKID problems have no single authority for driving requirements. And so there really is no single solution. To tease that apart, I want to kind of just take a moment to ground us in decision theory. And that's that decisions are made using two ingredients. Oops. The first is data. Data can be numbers, but it can also be qualitative evidence or anecdotal stories. For the sake of this talk, since this is the International Environmetrics Society, I'm going to give you a numbers example here. You could have two criteria that you care about, and you could collect data, and you may plot that on a curve, and you may see something like this. And then you say, well, I want to find the optimal solution. You simply take the derivative and you find that optimal solution as that red point. But you could also have something that looks like this, where you have multiple optimal solutions. And this is where the second ingredient for decisions comes into play, and that's the values. These are where costs and benefits of one over another play a role. And so it's really hard to train a machine to understand that value system if you're not baking that value system into the design of your algorithm from the beginning. And so this gets even more complicated when you introduce more parameters. So this is a three-dimensional space. So let's just say I'm buying a sandwich and I want it to be nutritious, yummy, and not too expensive. That is three parameters. if I were to go and collect all the data of all the restaurants in the area, which would be a lot of work to make this very trivial decision, and then map that into a space, and then take the derivative of that space, I would not find a single point or even a handful of points. I would find a line, because that's what happens when you take the derivative of a three-dimensional space. And that line has infinite points. And so you can see here that this is really, really essential, that values play such a crucial role, because how I value each of those criteria is going to really influence where I am in that space. So that's what a wicked problem is. So what is the wicked wildfire problem? Well, it's megafires. And megafires are becoming more common. What you can see here are fires in the United States from 1825 to present. And what you see on the left is, 30 of the worst burns. And these are not just the biggest burns. These are burns that burned a lot of houses or killed a lot of people. And then what you see on the right, these actually are the biggest fires, which in recent years have also been associated with impact. And so megafires are really the source of this wicked wildfire problem. But what is a megafire? It's actually a socio-political term for the fires that matter, or the fires that have negative impact. It can be related to size. It's very often equated to size, especially in the remote sensing community, because that's what's easy to measure from space. And big fires do matter. They matter for smoke. What you can see here are the fires from the 2020 California wildfire season, with smoke stretching across the North American continent, eventually into the ocean, and ultimately over to Britain. And so this can affect, values such as air quality, our ability to breathe, human health. Proximity matters for infrastructure. So what you can see here are that where we see fires are actually very close to where there are homes, and in fact, where there are many homes. Fast fires matter for lives. So this is the 2018 California Camp Fire that happened just in the Sierra Nevada mountains, right outside of Silicon Valley, which drew a lot of attention by tech innovators for entering into the wildfire space. The Camp Fire traveled 80 football fields in a minute. That is the equivalent to greater than 1 mile per minute of perimeter expansion. And just to put that into context for you, it takes about 15 minutes for the average wildland fire to be reported in the United States, about 45 minutes for fire management resources to be deployed to remote, hard to access locations. And the best resources in the world for suppression average, or even if you don't want to talk about suppression, containment, average production line rates of about 3,200 feet per hour, or about half a mile per hour. So the fire is growing greater than a mile per minute, and our ability to contain it is about half a mile per hour. So that means that containment and suppression is no longer an option, and our management options are really, where do we evacuate, what assets need protecting, and what do we do to protect them? So why are megafires a wicked problem? Well, fires have 3 ingredients, and there's no one authority over all of these ingredients. I'm going to focus today on the scale of decades to regions, and so I'll talk about the 3 ingredients of climate, vegetation, and ignitions. There we go. So climate change from greenhouse gases emitted from fossil fuels can result in warmer, drier, and more windy conditions. What you can see here is climate conditions projected out into the future and their impact on fire. So that's what these BI, ERC, DMC, all of these acronyms here are proxies for different fire behavior characteristics conditions that can influence fire behavior. And so you can see in general that we're seeing a worsening of the conditions for fire. And in fact, climate alone will increase the likelihood of very large fire events by 2 to 3 times, or 300 to 400%. Fuels, the second ingredient, and fire suppression in the United States have influenced what we're seeing happen and what's, making international news. I do want to call out that I recognize that the United States is not the only country experiencing fires. Siberia, much of the Mediterranean in Europe, and even Britain had some fires in the last year. So, and the tropics, Southeast Asia. So fire is everywhere, but my expertise is in the United States. So that's why that's the focus and emphasis of this talk. So thinking about the fire in the United States over the last 3,000 years, you can see that it's been variable. And in fact, burning coincides with natural warming and drying associated with solar cycles. Here you can see the medieval warm period where it was warmer, and guess what? We had more fire. And then we had the Little Ice Age and imperialism, which brought European settlers who assumed authority of the lands quite violently. And they also brought diseases and killed 56 million indigenous people. And the lands were left without prescribed and cultural fire. And so you can see not only is it cooling, but we're also not managing the landscape the way we had. And you see a huge deficit there. And then the climate began to warm again. And with that warming and extra fuels, because we had not been burning, fires happened and they killed people and they burned down homes. And this created an ecology of fear, which led to fire suppression. And ultimately, settlers learned in the 1950s that fire was really important and essential for our ecosystems. And they tried to bring fire back. But in the 1970s, with the Endangered Species Act, and the 1990s with National Ambient Air Quality Standards, there was a lot of bureaucratic red tape. And we struggle still to this day to figure how to balance endangered species habitat protection with air quality protections with prescribed burning. Now, I will tell you that I don't think that these have to conflict, but on the current system that we have, and because of the limitations of the metrics that we've been creating and the information tools that have been used, it has made it harder to prescribe burns. And this has resulted in fuel accumulation. Together, fuel accumulation can affect fire behavior in steep terrain in particular. So here is the 2014 California King fire with a model simulation that shows what would have happened to the fire if it had had half the fuels that it did, and it would not have spread nearly as fast as it actually did. So that blue perimeter was very close to the actual perimeter of the fire. And if we had had half the fuels, it would not have traveled nearly as fast. Both climate and fuel accumulation can affect fuel condition. So drought stress and tree mortality affect how flammable fuels are. What you can see here is the 2018 California Woolsey fire that happened after the 2012 to 2017 California drought, which led to a lot of mortality in vegetation. And you can see the mortality on the top as compared to the burn severity on the bottom. And the places that experienced the most mortality burned the most completely. So fuels are also affected by suburban sprawl. Very often we think in traditional fire ecology of fuels as plants, which is true, and suburban sprawl can certainly affect plants. Typically we think of it as introduction of invasives. So invasive grasses, to quote my boss, Jennifer Balch, are little arsonists. And so they're actually quite flammable. And this is a problem because they burn, and they burn frequently, and they burn hot, which means they deplete seed reserves, and they can change an ecosystem from what it was to something entirely new. But suburban sprawl can affect more than plants. It can also affect fuel in the form of homes. We have a growing wildland-urban interface with new fuels and little understanding of how they burn at landscape scales. So it's not just about thinking about the ignitability, but also the materials of the home and their ability to survive if they did ignite. Now this brings us to ignitions, and this is another area where people are affecting the fire triangle, that the three ingredients. People start many of the fires that matter. As you can see here, fires that are proximal to homes are actually started by people, as denoted by the red coloration as opposed to the blue. And in fact, when we look at the fire season, we can see that the fire season by lightning has a very distinct season. But when we think about humans and their influence on fire, it is throughout the entire year. And in fact, that peak at around day 165, that's the 4th of July here in the United States, when everybody is shooting off fireworks at possibly one of the driest times of year. So when you put all those ingredients together, the fires that matter, the mega fires, are the ones with high fire risk. And there are actually many players responsible. So fire risk is the accumulation of the hazard or the potential for something to happen, how vulnerable you are, and how exposed you are. We are just coming off the pandemic. Let me give you this in pandemic terms. The hazard was the probability that you could get COVID. The vulnerability was what demographic group you were in. Were you in the most vulnerable demographic group? And the exposure was whether or not you were going out and engaging in the world on a regular basis, right? And so all of that together was your COVID risk. Well, we use those three ingredients to denote risk in any context. And with respect to fire, exposure, vulnerability, and hazard are influenced by social, technological systems and ecosystems. And for each of those, different people are responsible for different parts of the equation. So how do we solve wicked problems? Well, that's why I created WKID Innovation for systematic change. And I noticed there's a number of people from JPL here. I do want to note that WKID Innovation is a derivation of what NASA does for innovating. And I have an 11-minute masterclass available on YouTube that describes how I developed WKID Innovation based on what I learned from my time at NASA. But there is a need to go beyond WKID Innovation as a framework for solutions-oriented science and using artificial intelligence to actually providing value-added analytics, right? We need to go from research to the day-to-day. And so for this, we have the University of Colorado Boulder has convened an alliance with Deloitte to enable climate action through what we're calling the Climate Innovation Collaboratory, with an emphasis on translating cutting-edge climate research and data into meaningful climate solutions. And so a big part of what we're doing with this in the initial stages is we're developing this research to commercialization model. And you can see there up at the top, we've got WKID Innovation, and I'm going to walk through all of these little boxes and what they mean. But we start with a change traceability matrix, and we map to a product traceability matrix, which has requirements, and we're all along the way, we're mixing this innovation science with the traditional human-centered design approach and agile development for product development with go-to-market strategy for developing a sustainable model to sell the product. So thinking about WKID Innovation and sort of breaking it apart, you saw this V model earlier. We're specifically focused on these first three, the W, the K, and the I. So starting with wisdom and working our way down to actually define our science based on the action it's going to change, as opposed to hoping our science results in change. So it's sort of thinking about it in reverse of the way that most people traditionally think about it. There's two tools that we use. We use the change traceability matrix, which maps the decision space to identify information needs and specifications. And we use the product traceability matrix, which provides high level requirements on product definition. So let me just walk you through the change traceability matrix. And it's exactly what it sounds like. It is traceable change, right? So it is using change management practices to set our requirements and understand the gaps and how to fill them. And we're specifically looking in the decision context. So this is the policy, the economics, the sociocultural, and the tools of the current space. And then using something called process knowledge mapping, which tells us about the intel that is needed for us to build trustworthy AI to actually influence that decision context. So what this actually looks like is that we start by defining a user persona. Who is the person that this is sort of targeted for? What are their key performance indicators? So these are the metrics that they use to evaluate success or to report success. So these, very often, like in very simple terms, this would be getting an A on your exam, right? Or playing well with kids at school, right? Those could be key performance indicators that somebody is looking at. And at the end of the day, they want to make sure that they're making decisions that improve how well they play at school or what grade they get on the exam. Then we map the decision space. Who is making what decision and how are they making it? And we link that to the motivators. So this could be funding, it could be policy, and it could be value systems. And this is really important because this is where a lot of requirements get set, and it can be quite subtle, right? Because of X policy, we need to be able to show that we're going to reduce the impact of carbon emissions by this amount if we go with this approach, right? That can have a very subtle requirement in it that if you're just designing your algorithm to provide information and you're not aware of the policy that's driving that information, you could get to the end of your science and say, well, here's the information. They go, yeah, but I can't use that, right? So these motivators are what are telling us how to make that information useful. And then the tools and technologies that they're currently plugging into and how to use them, along with the information that they're using. This could be information that is in the form of data, but it can also be information that somebody is just using as a human observing the landscape or their environment. The information is not always in the form of data, but as we enter into a world where we want to be leveraging and harnessing all the data available to us, this is a great place for us to understand what information has gaps. And that's really where we go into this next realm, which is the limitations and the opportunities of where we currently sit. And then finally, who the stakeholders are for that decision to make sure that we're building trust along the way and what they care about. So through the Climate Innovation Collaboratory, we've been mapping the landscape. We started with interviews by user archetype. So you can see here, we interviewed people from emergency responders to land management, preparedness, and resilience planning, public information officers, policy implementation and enforcement, as well as recovery. And I do want to take a moment just to say that this was a big group effort. There was a phenomenal amount of work that went into conducting these interviews. I certainly was not the one doing most of the heavy work here. So I want to recognize the value of the entire team at CEU for that, and Deloitte for helping with those interviews and collecting all that data. And what we did in these interviews is we made sure that the questions paralleled the structure to populate the change traceability matrix by archetype. And then we used the change traceability matrix. Once we synthesized everything into the change traceability matrix, we used that to inform the product traceability matrix, which gives us high-level change management requirements to innovate in the space. And I will show you some results from that in just a minute. And then we've been using the change traceability matrix to help inform human-centered design and the agile product development approach for providing the information via the value-added analytics via our AI. So from synthesizing across all of our interviews, we had 8 user personas total, which resulted in 39 user stories. So I want to be really clear that within a user persona, that's something like local land use resiliency planner. That could be a city council doing zoning. It could be a utility company. It could be anybody who really falls into sort of like resilience planning at the local scale. So that's why there's very broad categories of persona there. So there are 8 user personas, which resulted in 39 user stories total. And as you can see here, within the user personas, public perception is a really key piece of information, as well as dynamic risk across all of those personas, from pre-fire to active fire to post-fire. And we also looked within each of those personas on the specific decisions that they're making and the information that they would need. And you can see that even though public perception and dynamic risk served the same number of personas, public perception was actually used in a lot more decisions across personas than any other information variable that was there. And one thing I do want to note here is that risk is a function of exposure, vulnerability, and hazard. And so what you see here is when somebody explicitly said they need risk in forming a decision, or if they said, I explicitly need vulnerability defined some way. And so that's why it's broken out, even though risk combines vulnerability, exposure, and hazard. People would specify each of these differently. And so this is really important, because in 2 slides, I'm going to show you how we are able to actually take what was said in this mapping space to define how we develop the information of value. So one thing I do want to note is that some really key information gaps. Social media was a really big one. Specifically recognizing that we need to be able to filter out deep fakes, misinformation bots, and verified accounts. We need risk futures. So we need to project risk as defined by how it's actually messaged, rather than just acres burned under different management scenarios, and to link that to the cost of management to risk mitigation benefit, right? So this is really, we need to go a step further. We need to go beyond hazard of acres burned to actually mapping it to the decision space. Risk generally, what they're looking for is uncertainty by each layer. So instead of just giving risk as one value, they want to see it broken out, because that really influences things. Because you could have high hazard, but low exposure and low vulnerability. Think back to the pandemic example, right? The probability of catching COVID was very high, but let's say you worked from home and you didn't get exposed to very many people and you were in a non-vulnerable demographic, your risk was much different. So you need to disentangle what risk means. And then risk information should consider scalability beyond data limitations of the United States. So right now, a lot of the research is focused in the United States, and I am guilty of that in this presentation. But we recognize that this is a global issue, and that risk is very different in different places. And so also we need to think about the wildland urban interface. And so where and how humans are interacting with wildlands. And the effects that has on fire. With respect to hazard, we're looking at fuel maps that are updated frequently as fuels change. And vulnerability is related to building ignition potential today and into the future. Incident reporting right now is a very manual process, but we have all the data sources out there, and yet it's not automated. It could be, and certainly something Earth Lab is looking at within the United States. Exposure. So this is really looking at building locations today and likely locations into the future. And then finally, there's sort of other information gaps where we focus on proactive solutions rather than reactive. So there's a huge emphasis with people thinking, oh, fire is scary, fire is bad. What can we do to suppress the fire? And really what this requires is a shift in how we think. How can we think about the analytics that will support us to make proactive decisions? we need to have metadata, mostly so that we can meet that last point at the end to enable analytics by more than just the people who are creating the data products. We need to link building damage to actual insurance policies. And we need verified knowledge with verified information with local knowledge. And we also need to provide the granularity needed to inform decisions. And this kind of goes back to each layer within risk, hazard, exposure, and vulnerability. So what does this mean, like getting it down to the granularity and actually defining it the way that people are using that information? So here's an example of how we can define current risk. This is how a local land use, land management resilience planner defines current risk as changes in fire hazard and structures, structural exposure and structural vulnerability. And within this discussion and the decision mapping, we can see that they actually define what exactly they mean by hazard. It's, trees get cut down, removed from fire, structures are built and destroyed. And we need to think about structures as combustible fuels, as well as the locations of those structures, how stressed or sick our vegetation is, and what that means within the context of topography. From an exposure perspective, we need to think about the wildland urban interface maps at the parcel level. So we need these to be very granular. And then spatially. And then vulnerability is about the ignitability as well as the materials of the home. So not just would it ignite, but if it ignites, how burnable is it? So finally, from the change traceability matrix, we were able to map out some high-level requirements for actually innovating in the wildfire space. And that's to say that, information technology should be interoperable to plug into existing data portals by user persona to help reduce the number of sources and screens that they have to visit. Data platforms should plug into a single existing government data portal when one becomes available. It should be intuitive to interpret and to reduce training for use. Because the reality is that people need to spend time making decisions, not learning about how to make decisions. Technologies shall be accessible via cell phone or government laptop with limited connectivity. So recognizing where people are making these decisions and what kind of access they have. It needs to be available not just from technology, but also in printout form. What if somebody doesn't have technology? What if they have to literally print a map and go out into the field? You need to have provenance and have it be part of public record. The reality is that making decisions in the wildfire problem space is a liability, and you need to have a record and justification for why you're doing what you're doing. Meet objectives of federal funding sources while also servicing local and state decision needs. So this is really key. Right now, a lot of the funding is federal. But where decisions are being made is at the local and state level. And so what we care about and the questions that we're asking at the local and state are not necessarily commensurate with how federal dollars are being allocated. So there's room to innovate in the business model that we have for allocating these funds. And we need transparent documentation of our algorithms, which goes into trustworthy AI, as well as open source and uncertainty and error propagation. We need long-term access, right? Remember this liability thing that I just talked about. You can't make a decision and then have the information disappear and say, well, it was that when I looked at it. No, we need an actual long-term record of that. And then pre-processed and ready to use. People don't have time to actually work with data, right? They need to just pull it up and have the information available to them in the time that they have to make the decision. We need to incentivize more resilient behavior and penalize less resilient behavior. So places that are focusing purely on suppression, maybe we shouldn't be giving them as much money. Maybe we should be giving more money to groups that are working on hardening their homes or helping their communities to create defensible space. And we need to think about cybersecurity. This is really important. I know a big hot button topic issue, especially during the recent elections. And marketed to relevant agencies for using available information. And so most importantly, we really need to include a business model to better serve less advantaged communities without exploiting them. So recognizing that everybody needs to benefit from this intel and not just those who have the most money. Oops, sorry. There we go. So to summarize my talk, resilience technology is the synthesis and interpretation of diverse big data using artificial intelligence and data fusion across scales for solutions-oriented science to create value-added analytics that address questions in disturbance and resilience. Value-added requires consideration of sustainable solutions that can fund themselves, and so an emphasis on the research to commercialization process. And methods exist to help with designing AI algorithms that provide intel to change the decision space, such as WKID Innovation. And this can work with traditional approaches like human-centered design to developing commercial solutions for information technologies. So with that, I'm going to end and say thank you. I'll just sort of put a ping in there that there is an 11-minute masterclass on where WKID Innovation came from and how it relates with NASA's processes for innovation. I also have an open access manuscript through Research Technology and Management. And finally, I am open to suggestions. I'm looking to publish all of this, and I'm looking for ideas on an appropriate journal. So if you have any ideas, please feel free to shoot me something in the chat or send me an email. I also have a book, and I'm looking for agents. So if you have any leads for me, I'm really open to all of that. And with that, I will open it up to questions.
Oh my gosh. First of all, I invite everyone to unmute their microphone and let us give a round of applause to Natasha for this very, very complete presentation. Thank you so much.
Yeah, thanks so much.
Thank you so much, Natasha. Now, if any of the attendees wish to ask any question, you can unmute yourself. Also, you may write a question on the chat. The floor is open for questions, if anybody wants to. Okay,
yeah.
Let me.
I actually have a question, okay. So maybe I can start from. It was very, very interesting. All I want to say is that from my, my limited experience of, talking with multiple agencies, like it's exactly what is needed, like this interdisciplinary, synergy, and exactly what you're doing. That's the approach. I have a more specific questions on that. So one is, how much are you connected with insurance companies, and how much of insurance data they are willing to share? That's the first question.
Yeah, that's a great question. So we are working with an insurance company. We work more with their research arm. With respect to their data, the way that we kind of handle this is we use this decision mapping approach to work with data outside of their institution, but then give them the intel they need in the formats they need. So it's not just like, when I say format, I'm not just saying like GeoTIFF, right? I'm talking about like the information that is actually designed the way that they're thinking about the information, right? It's everything I just talked about. I'm giving them the information in the way that they're sort of thinking about it so that they can then go do internal analyses. So that's how we've worked with them. But I will say that what we're doing with the insurance companies is there's a huge black box around how wildfire is handled in what's called catastrophe modeling in natural perils. And so they're really interested in projecting risk out into the future because that's their entire business model. They're essentially playing odds, right? They're gambling with the future that they will be able to predict how much risk there is so that when they charge people, they're not going to undercharge and then have something happen and then go, oops, oh, we don't have enough money, right? So that's really their big emphasis. And right now, the way catastrophe models focus is they're very hazard focused. And even what I kind of showed you just at a high level. In fire ecology, we've been very narrowly limited in how we think about hazard as it just relates to climate, and we don't include the human component to that hazard factor. So there's room for development there, but they're also interested in how exposure and vulnerability, but particularly building exposure, might likely change in the future given climate change.
Okay, yeah, thank you very much. The other question I have is there's a lot of discussion right now about climate justice, and you partially mentioned all these communities, indigenous communities. So I just wonder, was you aware, I mean, you have done or you're aware of any studies who make it a little bit more quantifiable? So, I mean, there's anecdotal evidence, of course, that, you know, some communities are way more impacted than others. And
by climate change, is that
by wildfires particularly? I'm not talking just climate change in general, that's of course, but I mean wildfires in particular.
Yeah, there are studies, and I have to admit, I am not leading those studies. I know there's been some studies out of Humboldt, and I know Arizona has done some work with indigenous people. I know UC Merced. I'm happy to send some references. There is a really great person to follow on Twitter, Cultural Fire. I'll put it in the chat, but that is constantly putting out resources about the impact to indigenous people with respect to policy and our current management approaches.
Yeah, thanks very much. It would be because this is exactly where the climate justice context comes in. And if, kind of connecting it with something quantifiable, like what you really do, you run data analysis and, do some comparison and show that, yes, this is indeed, it's not simply by chance. That's what's going on.
Right.
Yeah, thank you very much.
Thank you.
Thank you, Julia. Scott, if you may ask the question.
Yeah, and I apologize. Apparently, I got a couple messages saying my camera had been on, and I thought it was off. So I apologize if that was the case. So my question, my name is Scott Kaplan. I'm with the USGS Civil Applications Committee. Are you working with other organizations like beyond just the research organizations, but the philanthropy organizations such as the Moore Foundation, the new one called megafire.org, and or others beyond just insurance? I'm the one that sent you the mirror board, so like the larger picture of all the other organizations that are involved.
Yeah, of course. So yeah, I've been working with a lot of those groups like Interra and TechnoSilva as well for many years. I've been in close communications with them. But yeah, a lot of kind of what I've personally been doing with those groups is more coordinating efforts. So I led like a study with the Keck Institute for Space Sciences that was kind of looking to define the actual problem space. And I'm happy to, Scott, if you send me a message and remind me, I will send you the report from that. And that report was sort of shared with, megafires.org and all these other groups. And we also convened a panel at the most recent International Association of Wildland Fire among these different groups to share what they're doing to make sure that it was sort of coordinated. So I can also share those resources with you.
Thanks.
Hi, Natasha. My name's Tim Bailey, and I'm with the Watershed Research and Training Center in Northern California. And I want to follow up on Yulia's line of thinking. And I'm curious how you assess the representation from user stories from organizations that are, or communities, I should say, that aren't kind of attached to the existing policy mechanisms. Like I think in the campfire, there's a lot of the narrative of the campfire is that that community was poorly represented in the policy space in advance. And as we look at the broadening footprint of these events, how do you kind of bridge the quality of the survey as you develop the product narratives?
Yeah, that's a great question. And It's really hard because I actually sit in this interesting space of like working with really, really big data and then doing qualitative studies where your like sample size is like several dozen. And so it's like very different problems, right? In big data space, you're like, how do you make sure you subset to make sure you're like sufficiently dealing with your confounding factors? And then in the sort of more qualitative space, you know, you're asking like, how do I make sure that I use my limited amount of resources to have a representative sample? So generally what we did was we binned people into these user archetype categories. And within each of those categories, there were sub sort of classifications. So for example, land use management and resilience planning, there was like city planning, utilities, insurance, reinsurance, you know, there was a couple different groups. And then we reached out to find different people who could speak to us generally about what was happening. So obviously they spoke about their internal process, but they would also sort of generally speak. And so we tried to get people from local, state, and national/international levels. So we heard about policies from different groups. And then we also tried to go across gradients of rural to urban. So recognizing that rural communities typically are underrepresented. And then like also recognizing that rural communities usually aren't as tech heavy. So that was kind of how we did it. But, you know, the sample size gets whittled down. And so what ends up happening is you're trying to find sort of, again, archetypes of a person to explain like general process rather than getting down into the nitty gritty of like, with campfire specifically, this is what happened. It's more like you're kind of finding people who have worked on many campfires, who have worked on, you know, like they're not working on one incident, they're working on many, and they can kind of generalize their findings as an archetype of that persona, if that makes sense.
Yeah, absolutely. I mean, this is fantastic work, and I'm looking forward to seeing more of it. Thank you so much.
Yeah, thank you.
Anybody else has another question?
I will say we are looking to publish all this. So if you have any journal ideas, it's really hard. It's interdisciplinary. And so it's hard to find the right outlet. So if you have any ideas, I'm open to it.
I'm glad that you mentioned that, because actually that was one of my questions. Where do you publish your work? Yeah, thank you. Yeah, hopefully someone will reach out.
I will publish it mind over matter, but it will be hard, I'm sure, because finding the right audience is tricky.
That's true. Okay, if there are no any questions, well, many thanks to all participants for attending this TIES webinar. You may keep an eye in our website, environmetrics.xyz. See you in our next webinar. Have an excellent rest of the day.
Thank you. Bye, everybody.